Hello everyone, welcome back to our channel. So today we are going to see about the Theorem 1 mathematical analysis. And the statement is, if P2 is a refinement of P1, then i.e. P2 is a refinement of P1 is nothing but P1 is subset to P, then prove the first one, L of P1 comma F comma alpha is less than or equals to L of P comma F comma alpha. And second condition, here P2. P1 comma F comma alpha is greater than or equals to U of P2 comma F comma alpha. And proof. Let F mapping A to B tends to R be a bounded function ఇక్కడ మనకు ఫస్ట్ ఏమి ఇచ్చారంటే స్టేట్మెంట్ P2 అనేది రిఫైన్మెంట్ ఆఫ్ P1. This is nothing but P1 is subset to P. Then we have to prove the lower RS sum is less than or equals to lower RS sum of partition P2. These P1 and P2 are nothing but the partitions. And upper sum of partition P1 is greater than or equals to upper sum of partition P2. And let alpha mapping A to B tends to R be a monotonically increasing function. Be a monotonically increasing function. And the given part is P2 is a refinement of P1. Therefore, write here given P1 comma P2 are the partitions and P2 is a refinement of P1, then we need to prove, write these two conditions. L of P1 comma F comma alpha is less than or equals to L of P2 comma F comma alpha. And the second one is U of P1 comma F comma alpha is greater than or equals to U of P2 comma F comma alpha. Okay, and let P1 be a partition on closed interval a comma b such that P1 is equals to a is equals to x0 comma x1 comma x2 comma x3 so on up to xr minus 1 and xr and up to so on xn. This is equals to b. And here given P2 is a refinement of P1, P1 is subset to P2, so we have P2 has P2 be a partition on closed interval a comma b such that P2 is equals to a is equals to x0, x1, x2, x3 so on xr minus 1 comma x star comma xr up to xn, which is equals to b. Here in the P1 we get only xr minus 1 and xr, but in the P2 partition we get xr minus 1, x star, xr and xn. Is it clear up till now? And then we will go into the next steps. let infimum f is equals to small mr and supremum f is equals to capital MR. These infimum and supremum are in closed interval xr minus 1 and xr, comma xr. And infimum f is equals to q1 and supremum f is equals to s1. Let us consider this. These are in the closed interval xr minus 1 comma x star, this interval, and infimum p2 in the p2 partition. Infimum f is equals to q2 and supremum f is equals to s2. These are in x star comma xr. These two are taken from the partition P2 and this one is assumed from the partition P1. Okay, and we have if A is subset to B, then supremum A is less than or equals to supremum B and infimum A is greater than or equals to infimum B. And we have in the place of A P1 and in the place of B we have P2. P1 is subset to P2. So from this we need to write supremum A is less than or equals to supremum B and infimum A is greater than or equals to infimum B. And please do remember this one. So here P1 is subset to P2. So we have supremum A is less than or equals to supremum B. So this MR supremum F is less than or equals to supremum. If we consider it as supremum A and supremum B, then S1 is less than or equals to capital MR and S2 is less than or equals to capital MR. And now if P1 is subset to P2, then infimum A is greater than or equals to infimum B. And consider infimum A has Q1. Then Q1 is greater than or equals to MR. Q1 is greater than or equals to small mr and Q2 is greater than or equals to small mr. Q2 is greater than or equals to small mr. Okay. In order to prove these two conditions, let us take this first one now. In order to prove the first one, it is enough to prove that L of P2 comma F comma alpha minus L of P1 comma F comma alpha is greater than or equals to 0. Okay. Now consider the LHS part. L of P2 comma F comma alpha minus L of P1 comma F comma alpha, which is equals to M1 into delta alpha 1 plus M2 into delta alpha 2 and plus so on. And we are in partition P2, right? And in the partition P2, what we will get? These are two are taken from the partition 2 and this is from partition 1. So these are from the partition 2, right? And we have L. So we get infimum. Okay? And Q1 plus Q1 into alpha of B minus alpha of A. This is B and this is A. Therefore, alpha of B is X star. alpha of x star minus alpha of xr minus 1. xr minus 1 plus and q2 also. Partition p because q2 into this is b and this is a. Alpha of d which is xr minus alpha of a x star and up to plus so on mn into delta alpha n and close this bracket and we have minus here and p1 partition. In p1 partition we have only this one which is nothing but the same m1 into delta alpha 1 plus m2 into delta alpha 2 plus up to so on mr into infimum because lower r is sum we get small mr which is infimum and mr into this is b and this is a. So alpha into b which is xr minus alpha into xr minus 1 and close this and have a plus mn into delta alpha n and close this one. Okay, and now what you need to do is m1 write the same part again plus m2 into delta alpha 2 plus so on q1 alpha x star minus alpha xr minus 1 plus q2 into alpha xr minus alpha x star plus so on mn into delta alpha n minus m1 into delta alpha 1 plus m2 into delta alpha 2 plus up to so on. Here what you need to do is in this one you need to add and subtract alpha into x star plus mr into alpha xr minus alpha x star. I am subtracting and I am adding. Why I am subtracting and adding here? Because in order to take common here alpha x star minus alpha xr minus 1. So I need to add this term also in this so that I can take common from this both and we can eliminate those terms so that we get this proof. We get the first proof, this one. And now from these terms m1 delta alpha n alpha 1 minus m1 delta alpha 1 cancel m2 delta alpha 2 plus and minus m2 delta alpha 2 cancel plus mn delta alpha n and minus here you get plus mn delta alpha n plus mn delta alpha n minus mn delta alpha n. So these terms cancel and you remain with this one q1 into alpha x star minus alpha xr minus 1 plus q2 into alpha xr minus alpha x star minus mr alpha xr minus alpha x star plus alpha x star minus alpha xr minus 1. And from this, if you see it carefully, we can take common alpha x star minus alpha xr minus 1. Alpha x star minus alpha xr minus 1. Take common from this q1 and mr. Then you get alpha x star minus alpha xr minus 1 into q1 minus mr plus, and in this, see here, alpha xr minus alpha x star, and we have alpha xr minus alpha x star. So take this term common from these both terms. So alpha xr minus alpha x star, which is q2 minus mr. And if you see here, greater than or equals to 0. So greater than or equals to 0, greater than or equals to 0, and greater than or equals to 0, and LHS part, which is nothing but L of P2 comma F comma alpha minus L of P1 comma F comma alpha is greater than or equals to 0. Here in the first, we have considered L of P2 comma F comma alpha minus L of P1 comma F comma alpha is this formula, right? So this is greater than or equals to 0. Then I substituted here. This total term is nothing but L of P1 P2 comma F comma alpha minus L of P1 comma F comma alpha, which is we got greater than or equals to 0. And then L of P2 comma F comma alpha is greater than or equals to L of P1 comma F comma alpha, which we can write it as L of P1 comma F comma alpha is less than or equals to L of P2 comma F comma alpha. This is, and the second condition, which is of same, in the place of L you need to substitute U. That's it, and I'll show you that also. And in order to prove second one, it is enough to prove that U of P2 comma F comma alpha is U of P2 comma F comma alpha minus U of P1 comma F comma alpha is less than or equals to 0. Here be careful. In when we take lower RS sum, it is greater than or equals to 0. But here it is less than or equals to 0. Please take care of this symbols. Okay? Greater than, less than. And now same. U of, consider this LHS part, P2 comma F comma alpha minus U of P1 comma F comma alpha, which is equals to M1 into delta alpha 1 plus M2 into delta alpha 2 plus so on. And we are in partition P2. In P2 there are 2. So we get, and U, upper RS sum. So this is upper RS sum, we get capital MR, right? So which is nothing but the supremum, capital MR supremum, plus S1, and this is A and this is B, which is nothing but the S1 into alpha B minus alpha A. Alpha B is X star minus alpha XR minus 1, XR minus 1 plus S2 into, this is A, this is B, alpha XR minus alpha X star, and plus up to so on, Mn delta alpha n. Now minus, we are in partition P1, which is nothing but this is taken from the partition P1, and M1 delta alpha 1 plus M2 delta alpha 2 plus so on, capital MR, upper RS sum. The upper RS sum formula is summation R is equals to 1 tends to n MR delta alpha R, right? Capital MR, supremum. So capital MR into alpha, this is nothing but alpha b minus alpha a. Therefore, this is a, this is b. Alpha xr minus this is r and minus alpha xr minus 1 and plus up to so on mn delta alpha n. And now here in the LHS we have added and subtracted x star. Here also do the same for this part. ఈ క్యాపిటల్ ఎంఆర్కి ఏదైతే ఉందో ఇక్కడ ఆల్ఫా ఎక్స్ స్టార్ అనేది యాడ్ చేయండి, సబ్ట్రాక్ట్ చేయండి, ఎందుకంటే ఇక్కడ కామన్ తీసుకోవాలి కాబట్టి. ఇన్ ఆర్డర్ టు గెట్ కామన్ దీస్ టర్మ్స్ యాడ్ అండ్ సబ్ట్రాక్ట్ దీస్ బోత్ హ్యాస్ వి డన్ ఇన్ ది ఫస్ట్ పార్ట్. సేమ్ ఇదంతా సేమ్ రాసుకోవాలి. m1 delta alpha 1 plus m2 delta alpha 2 plus so on s1 into alpha x star minus alpha xr minus 1 plus s2 into alpha xr minus alpha x star plus so on mn delta alpha n minus m1 delta alpha 1 plus m2 delta alpha 2 plus so on mr capital mr alpha xr minus alpha xr minus 1 plus alpha x star minus alpha x star plus so on mn delta alpha n. సో ఇక్కడ చూడండి m1 delta alpha n plus m1 delta alpha n and minus m1 delta alpha n, so cancel, and plus m2 delta alpha 2 minus into plus minus plus m2 delta alpha 2 minus m2 delta alpha 2, so these term also cancel and these term get cancelled. So we remain with s1 alpha x star minus alpha xr minus 1 plus s2 into alpha xr minus alpha x star plus capital mr into alpha xr minus alpha x star plus alpha x star minus alpha xr minus 1. So if you see the first one, alpha x star minus alpha xr minus 1 and alpha x star minus alpha xr minus 1. So from these both terms I can take common this one. So I get alpha x star minus alpha xr minus 1 and plus s1, and here minus into plus minus, so here I get minus and minus capital mr, and in the same way alpha xr minus alpha x star, alpha xr minus alpha x star, so I can take common, which is alpha xr minus alpha x star. So I get s2 minus mr minus capital mr. This is less than or equals to 0. And see here, so u of p2 comma f comma alpha minus u of p1 comma f comma alpha is less than or equals to 0, which is nothing but u of p2 comma f comma alpha is less than or equals to u of p1 comma f comma alpha. Therefore I can write it as u of p1 comma f comma alpha is greater than or equals to u of p2 comma f comma alpha, and we proved second one also, hence proved. And if you have any doubts, Please do comment in the comment box and like the content. Please do subscribe to my channel if you are new to my channel, and for more updates and for more videos, stay tuned to our channel Sunaina_MSc. Thank you all. Happy learning to you.